In the last video, we had a word problem where we essentially had to figure out the sides of a triangle, but instead of just being able to do the Pythagorean theorem and because it was a right triangle, it was just kind of a normal triangle, and it wasn't a right triangle, and we just kind of chugged through it using SOHCAHTOA and just our very simple trig functions, and we got to the right answer. What I want to do now is introduce you to something called the law of cosines, which we essentially proved in the last video, but I want to kind of prove it in a more, without the word problem getting in the way. And I want to show you, once you know the law of cosines, you can then apply it to a problem like we did in the past, and you'll do it faster. I have a bit of a mixed opinion about it, because I'm not a big fan of memorizing things. When you're 40 years old, you probably won't have the law of cosines still memorized, but if you have that ability to start with the trig functions and just move forward, then you'll always be set. And I'd be impressed if you're still doing trig at 40, but who knows? So let's go and let's see what this law of cosines is all about. So let's say that I know this angle theta. I know this angle theta. And I know, let's call this side, I don't know, A. Let's call this side B. I'm being a little arbitrary here. Let's call that, actually let me stay in the colors of the side. So that let's call that B. And let's call this C, and then let's call this side A. So if this was a right triangle, then we could have used the Pythagorean theorem somehow, but now we can't. So what do? So we know A. Well, let's assume that we know B, we know C, we know theta, and then we want to solve for A. But in general, we can. As long as you know 3 of these, you can solve for the 4th, and once you know the law of cosines. So how can we do it? Well, we're going to do it the exact same way we did that last problem. We can drop a line here to make, oh my god, that's messy. I thought I was using the line tool. Edit, undo. Undo. So I can drop a line like that. I'm trying to make it. So I have 2 right angles. And then once I have right triangles, then now I can start to use trig functions and Pythagorean theorem, etc., etc. So let's see. So this is a right angle, and this is a right angle. So what is this side here? What is? Let me pick another color. I'm probably going to get too involved with all of the colors, but it's for your improvement. So what is this side here? What is the length of that side? That purple side? Well, that purple side is just, we use SOHCAHTOA. It's good to write SOHCAHTOA up here. SOHCAHTOA. So this purple side is adjacent to theta, and then this blue or mauve side, B, is the hypotenuse, right, of this right triangle. So we know that. Actually, I'm going to stick to one color because it'll take me forever if I keep switching colors. We know that cosine of theta. Let's call this side. Let's call this kind of subside. Let's call this, I don't know. Let's call this D. Side D. We know that cosine of theta is equal to D over B, right? And we know B. Or that D is equal to what? It equals B cosine theta. Now let's call this side E, right here. E. Well, what's E? Well, E is this whole C side. Oh, that's interesting. This whole C side minus this D side, right? So E is equal to C minus D. We just solved for D. So side E is equal to C minus B cosine of theta. B cosine of theta. So that's E. We got E out of the way. And what's this magenta side going to be? Well, let's call this magenta. Let's call it M for magenta. M. Well, M is opposite to theta, and so if what involves, well, we know it. We've solved for C as well, but we know B, and B is simple. So what relationship gives us M over B, or involves the opposite and the hypotenuse? Well, that's sine, opposite over hypotenuse. So we know that M over B is equal to sine of theta. We know that, let me go here. M over B, right, because it's the hypotenuse, is equal to sine of theta or that m is equal to b sine of theta, right? So we figured out m, we figured out e, and now we want to figure out a. And this should jump out at you. We have two sides of a right triangle, and we want to figure out the hypotenuse. We can use the Pythagorean theorem. This Pythagorean theorem tells us a squared is equal to m squared plus e squared, right? Just the square of the other two sides. Well, what's m squared plus e squared? Let me switch to another color just to be arbitrary. So a squared is equal to m squared. M is b sine of theta, so it's b sine of theta squared plus e squared. Well, e we figured out is this. So it's plus c minus b cosine theta squared. Now let's just chug through some algebra. So that equals b sine b squared sine squared theta. Sine squared theta just means sine of theta squared, right? Plus, and we just FOILed this out. Although I don't like using FOIL, I just multiply it out. But c squared minus 2cb cosine theta plus b squared cosine theta. Right? I just expanded this out by multiplying it out. And now let's see if we can do anything interesting. Well, if we take this term and this term, we get that those two terms are b squared sine squared of theta plus b squared cosine. There should be a squared there, right? Because we squared it. B squared cosine squared of theta. And then we have plus c squared minus 2bc cosine theta. Well, what does this simplify to? Well, this is the same thing as this equals b squared times a sine squared theta plus cosine squared of theta. Something should be jumping out at you. And then that's plus c squared minus 2bc cosine of theta. Well, this thing, sine squared plus cosine squared of any angle is 1. That's one of the early identities. That's just, that's a Pythagorean identity right there. So this equals 1. So then we're left with, going back to my original color, we're almost there. A squared is equal to, this term just becomes 1, so b squared, we're just left with a b squared, right? Plus c squared minus 2bc cosine of theta. That's pretty neat. And this is called the law of cosines. And it's useful because, if you know an angle and two of the sides of any triangle, you can now solve for the other side. Or really, if you want to, if you know three sides of a triangle, you can now solve for any angle. So that also is very useful. The only reason why I'm a little bit, here, there is it is good. If you are in trigonometry right now and you might have a test, you should memorize this because it'll make you faster and you'll get the answer right quicker. I'm not a big fan of just memorizing it without knowing where it came from, because a year from now or 2 years from now when you go to college and it's been 4 years since you took trigonometry, you probably won't have this memorized. And if you face a trig problem all of a sudden, it's good to kind of get there from scratch. But with that said, this is the law of cosines, and if you use the law of cosines, you could have done that problem we just did a lot faster, because you just have to set up the triangle and then just substitute into this, and you could have solved for A in that ship off course problem. I'll see you in the next video.